My name is Jeffrey Frankel, and in this series of YouTube videos I will show you techniques and tips to reduce the time it takes to deal with questions in paper 1 of the IB chemistry exam at both standard level and higher level. In this sentence, the examiner is asking you if you understand that the meaning of the word spontaneous is, does the reaction go to completion? What you have to do is remember a concept, or maybe two concepts, that you learned maybe a year or 2 years ago. And the first concept is that chlorine is more reactive than bromine, which is more reactive than iodine. So chlorine is more reactive than bromine, and that is more reactive than iodine. This you learned as part of the characteristics of the halogens in the periodic table. At the same time, you also learned that chlorine would displace bromine in a solution. So chlorine is displacing the bromine from the bromide ion to give bromine plus the chloride ion. And that bromine is displacing iodine from the iodide ion to give iodine and the bromide ion. There is, of course, the third equation, which is that chlorine will, of course, displace iodine, which is obvious from plus 2Cl minus. Okay, so that's obvious from that. If chlorine displaces bromine and bromine displaces iodine, then chlorine will displace iodine. The answer to the question, which of the following reactions is or are spontaneous, is that both are spontaneous. So both 1 and 2. That's a very simple one, and it required nothing more than information that you had acquired in the past. When you look at this, it shouldn't really take you more than 10 or 15 seconds to realize that both these reactions go to completion, and therefore the answer is C. Just to complete the concept of spontaneous, I'm going to write down the following. That is that I2 plus 2Br minus goes to Br2 plus 2I minus. Now, in the past, a year or 2 years ago, you would have been expected to say no reaction. Today you're expected to say this is not spontaneous. This is not a spontaneous reaction. In other words, this does not go to completion. And it's the same for the others. The Br2 plus 2Cl minus goes to Cl2 plus 2Br minus. In the past you said simply no reaction. However, now you're expected to say that this is not a spontaneous reaction. This one is very similar to the previous one, except there's an addition to it, this concept of oxidizing agent or reducing agent. As before, I said that chlorine is more reactive than bromine, which is more reactive than iodine. So we start with that, and then the question is, in terms of reaction, what does it do? Well, if you look at this, the Br minus loses electrons and goes to Br, or Br2. In other words, the Br minus is oxidized. So chlorine is an oxidizing agent. From this and this, we can see that chlorine is the strongest oxidizing agent. And therefore iodine is the weakest oxidizing agent. Okay, simply because chlorine displaces bromine, bromine displaces iodine. Therefore, chlorine oxidizes bromine, bromine oxidizes iodine. It doesn't go in the other direction. Now, something does go in the other direction, and let's look at it. What is the bromide ion doing to the chlorine? Well, the chlorine is being reduced to chloride ion. Therefore, bromide ion is more powerful than chloride ion as a reducing agent. And here we can see that iodine ion is more powerful than bromide ion as a reducing agent. So what we have is the iodine ion is more powerful than the bromide ion, which is more powerful than the chloride ion. So that's the strongest reducing agent. And chloride ion is clearly the weakest. So it's important for you to see these two ideas, that in terms of oxidizing agent, chlorine is the most powerful oxidizing agent. In terms of reducing agent, iodine ion is the most powerful reducing agent. And therefore, when you look through here, strongest oxidizing agent, well, there's chlorine and chlorine, and we are therefore going to iodine ion. So this C is the answer. Now this one does take a little bit longer to do than the previous one, but it can be done when you see these two reactivity series. They are still reactivity series. Chlorine is more powerful than bromine, which is more powerful than iodine. Iodide ion is more powerful than bromide ion, which is more powerful than chloride ion. And this is a oxidizing agent series, going from the strongest to the weakest. This is a reducing agent series, going from the strongest to the weakest. This is again an example of the reactivity series that you came across in maybe a year or 2 years ago. And you would remember that zinc is clearly more reactive than silver. And from this you can work out the full range, that zinc is more reactive than iron, Fe, which is more reactive than copper, which is more reactive than silver. So even if you didn't remember this series, then you can work it out from these three equations. Notice that there are 4 elements involved, and 3 equations are sufficient to tell you the order. Now, what is the zinc doing? It is changing the Fe2 plus to Fe. In other words, it is a reducing agent. So it's the strongest reducing agent. Strongest reducing agent. When we look at the ions, the order is in the opposite direction. So it's Ag plus. Ag plus is more reactive than Cu2 plus, which is more reactive than Fe2 plus, which is more reactive than Zn2 plus. And you can confirm that by looking at the silver ion oxidizes copper metal to Cu2 plus. The Cu2 plus oxidizes Fe to Fe2 plus, and the Fe2 plus oxidizes zinc to Zn2 plus. So therefore, this is the strongest oxidizing agent. Oxidizing agent. Okay, so now we have all the information we need to answer this question. What is the strongest oxidizing agent? Well, we know it's Ag+. Oh, lo and behold, it is this one. Let's just check that it comes with the strongest reducing agent, and the strongest reducing agent is zinc, Zn. So B is clearly the answer here. what you need to do is simply work out the order of reactivity for both the metals and then for the ions. And once you've done one order of reactivity, the other one is simple. It's just the reverse. Go zinc, more reactive than Fe, more reactive than Cu, more reactive than Ag. The ions are in the reverse order. Ag plus, more reactive than Cu2 plus, which is more reactive than Fe2 plus, which is more reactive than Zn2 plus. One thing to be aware of is that in every pair, let's say Zn and Zn2 plus, if one part of the pair is the strongest reducing agent in the series, then the other part will be the weakest oxidizing agent. And if one part of the pair is the weakest reducing agent, then the other part of the pair will be the strongest oxidizing agent. The examiner is telling you in this problem that the following reactions are spontaneous as written, and therefore he is telling you the order of reactivity. He's telling you that Fe is more reactive than cadmium, and that cadmium is more reactive than tin, and tin is more reactive than lead. So you can write that down, that Fe is greater than Cd, which is greater than Sn, greater than Pb. And what is the iron doing? It is reducing the cadmium. So it's the strongest reducing agent. Strongest reducing agent. So from that, you can go immediately to these and decide which pair will react spontaneously. If you look at this one, the iron and Pb, iron is the strongest reducing agent, therefore that one is spontaneous. Cadmium, lead, again, looking at that group, cadmium is the strongest reducing agent, so it will be spontaneous. Tin and iron, no, they're in the wrong order. Therefore, tin is less reactive than iron. Therefore, that is not spontaneous. So 2 and 3, that D. Now, it doesn't matter whether you looked at it from the reducing agent point of view, iron is stronger than cadmium, is stronger than tin, is stronger than lead, or you looked at it from the oxidizing agent point of view, the actual ions of these metals. Let's look at it from that point of view. You can see from these three that Pb2 plus is the strongest oxidizing agent. So Pb2 plus is stronger than tin, Sn2 plus, which is stronger than cadmium, 2 plus, which is stronger than Fe2 plus. Okay, so that's the strongest oxidizing agent. And you will see that therefore this one, because Pb2 plus is the strongest, this one is spontaneous. Pb2 plus is the strongest, this one is spontaneous. Fe2 plus is the weakest, this one is not spontaneous. We come to the same answer, that D is the correct one. This is again one of those questions where it is important for you to be able to look at these kind of questions and quickly write down the order in which they react, their reactivity order. If it's a reducing agent, you work out the strongest and work down until you get to the weakest. If it's an oxidizing agent, you work out the strongest and work down until you get to the weakest. If there are only two equations given to you, then there are only three item, there can only be 3 items in the list, and so it becomes easier to see the strongest and the weakest, and then the other one must be in the middle for both of these. If there are 3 equations given to you, then there are going to be 4 of these, and it's best to work them out in iron is strongest, then cadmium, then tin, then lead. Pb2+, then Sn2+, then Cd2+, then Fe2+. So as you can see, there are 2 different ways, or possibly 3 different ways they can ask these kind of questions. They can ask them in this work form, are the following spontaneous or not? Or they can ask them in the form, which is the strongest reducing agent, which is the strongest oxidizing agent, or not. This one is clearly similar to the previous ones, except that the examiner is checking whether you understand the principles and you can use symbols instead of known elements in the equations. And the elements concerned here, P, Q, R, and S. One can guess that they are probably metals because the ions have a 2 positive charge. But in a way, that's not relevant. The important thing is what is the order of reactivity. There are only 3 equations, and it is quite easy to determine the order. Let's see that P is more reactive than Q, which is more reactive than R, which is more reactive than S. So that's clear in terms of the elements. Now, what is P doing to Q? Q2 plus is going to Q. So Q2 plus is being reduced. So P is the strongest reducing agent. And as before, we are now going to go to the ions, and we know it's in the reverse order. So it's S2 plus is greater than R2 plus, which is greater than Q2 plus, which is greater than P2 plus. And you can confirm that that is the order in that you look at S2 plus, it is oxidizing R and to R2 plus, and R2 plus is oxidizing Q to Q2 plus, and Q2 plus is oxidizing P to P2 plus. So that is the correct order for oxidizing agents. So that's the strongest oxidizing agent. So we have all the information we need in order to answer the question. Which is the strongest oxidizing agent? It's S2 plus. So we go down here, well, there is only one of them. Let's just check that it fits with the strongest reducing agent. Strongest reducing agent is P, so that's there, P. So there we go. D. So there are a number of things to remember. The first is get the order of the elements in terms of their reactivity first. Check whether they are reducing or oxidizing. Remember that metals do reducing and non-metals such as chlorine are oxidizing elements. And then do the ions, and remember that the order is the complete opposite for the elements, and that if the element is a reducing agent, then the ions are oxidizing agent. And remember, the simple rule, which is useful sometimes, is that if P is the strongest reducing agent, its ion is the weakest oxidizing agent. And if S is the weakest reducing agent, then its ion is the strongest oxidizing agent. And that doesn't matter whether the elements are metals, as they are in this case, or a series of non-metals. This is one of those that takes a little bit of time to work this out, the order, and then whether it's a reducing agent or oxidizing agent, and then you put this down because, and this becomes easier because it's the opposite of the first one. And then you decide where they are in these 2 lists, and that's the answer. The concept of spontaneity applies to both organic chemistry as well as inorganic chemistry. And in this case, it's simply a matter of knowing the chemistry. We have here ethanol, and that's a primary alcohol. And this is dichromate, probably potassium dichromate. That's the usual form in which it's used. And this is some acid, possibly hydrochloric acid or sulfuric acid. The result is, as you should know, that the alcohol is oxidized by dichromate to the aldehyde, that's ethanol. And the dichromate part is reduced to Cr3+. So that one does go to completion, and therefore that one is spontaneous. The same here, the aldehyde with dichromate, potassium dichromate, some acid, will go to ethanoic acid. So that one does go to completion, and that one is spontaneous. Here we have something slightly different. We have a ketone, and we have Cr3+, which is a reducing agent. If that is the oxidizing agent, then that is the reducing agent. However, we know that this is not reduced by Cr3+, because in practice the reaction goes in the opposite direction. This alcohol, which is a secondary alcohol, will be oxidized by the potassium dichromate in the presence of an acid to the ketone, propanone, and give the Cr3+. So whereas Cr2O7, 2-, is a powerful oxidizing agent, the Cr3+ is a very weak reducing agent. And this is not spontaneous. This does not go in this direction. It goes in the other direction. So the only ones that are spontaneous are 1 and 2, D. If you found this YouTube video helpful, please say you like it and subscribe to my channel and look at my other YouTube videos. Thank you.